This conference will now be recorded.
Hello students, very good evening to all of you. Today we are starting the revision part. So first, as we had Tuesday and Sunday, Tuesday and Thursday, we will be discussing or will be revising chapters from 11th standard, and Wednesday and Sunday we'll be discussing various questions from JEE papers from the 12th standard. Okay, so we have started the revision part since beginning kinematics with the kinematics. So these are problem mostly based on the previous JEE and NEET papers. We'll really do this revision very thoroughly. We'll be discussing the numerical problems. At the same time, we'll be discussing the corresponding concepts lying behind the solution of the problem. Okay, so here the first problem is from projectile motion. You can read this problem that a projectile is given an initial velocity. Oh, there is a typo here. This is meter per second. Meter per second. Initial velocity I plus 2j meter per second. Okay, basically this is I cap plus 2j cap meter per second. So this velocity is given to a projectile, where I cap, we know I cap is along the ground. It is like this. Okay, this I cap along x-axis and j cap along the vertical direction that we generally take as y direction. Okay, and g is given as 10 meter per second square. This is the acceleration due to gravity, as you know. Then you have to find out the equation of the trajectory. So how to find out the trajectory for this problem, for this particular projectile? See, this problem is given, you know, this the projectile is given a velocity I cap plus 2j cap. Here is the clue. And to solve this problem, first of all, you must be remembering the trajectory. If you remember the trajectory, that is very good, all and good. Otherwise, for today, since we are doing this problem after a long time of the topic has been covered, so I'll just tell you, if you suppose don't remember the particular formula, it is actually mandatory to remember, otherwise you will not be able to get time in the exam hall to complete all the things. If you derive the formula and come back to solve the problem, so you must be remembering the formula. But for today, I'll tell you how to derive this particular formula also, so that you don't forget it. So how to derive this formula? Suppose a projectile has been given a velocity along a direction which is making an angle theta with the x-axis or I cap. So suppose this is the total velocity having magnitude u, and it has component ux and uy as well in this direction. Okay, so as we know, the trajectory will be something like this. This is a parabola. But how to find out the formula for this particular problem? So let us just do one thing. See, when the projectile reaches over here, let us say at any point, suppose at any point p x comma y, okay, x comma y, it is actually, suppose in the initially at t is equal to 0, the projectile was at this position, particular position, origin 0, and after some time t, suppose the projectile is at here xy, this is the position xy. So you have to actually, trajectory means what, you have to find out the relationship between x and y with respect to, like you have to find out a relation between x and y. We don't know what is the relation between x and y. You have to find out a relation between x and y, so that will give you the trajectory. So to find out that, first of all, you can see after time t, after t time, what is the x horizontal distance along the t time horizontal distance covered? That will be x horizontal distance. That will give you x. X is equal to ux into t. Ux into t. So what you get? T is equal to u by, sorry, x by ux. Okay. So that is what you get. Okay. Now what about y? Y will be, see, initially suppose the velocity was 0. Initially at t is equal to 0, velocity was 0. That is what we will be taking here. So we know u along the y direction, uy t, uy, no, I should not be taking t is uy is equal to 0 here, because in general we are trying to find out. So ut minus half g t square. Okay. So this ux is actually, ux is u cos theta, u cos of theta, and uy, this uy is actually u sin theta here, e cos theta. So you just put the value of the time over here, and ux and uy. Uy is u sin theta, so we'll write u sin theta, and t means x by u cos of theta. So this is one part. Then minus half g t square. T square is actually x square by u square cos square theta, as you see from here. Okay, using this, suppose this is 1, using this 1 we get this. Okay. Okay, so I hope this, so from here, if you just simplify it, what do you get upon simplification? See, you get cancelled, so it will be sin theta by cos theta, so this will be x tan theta. I'm just writing here itself because the space is less, so it will be x tan theta. I hope you agree with me. If not, you just do by yourself and then see, it will be the same. Okay, so this is minus, see, this is x square, this is u square. I'll keep this as it is, but I need some space here, so I'll just erase it and write it here again. So let me write what we get as trajectory y is equal to x tan theta minus gx square by 2 u square cos square theta. So this is the trajectory. So this is the formula for the trajectory at any point of time, okay, for a projectile. Okay, so hope you will be able to do it and you will be remembering this formula positively. Now what I'll do, I'll just remove this part and I'll try to solve this problem using this formula, because numerical problem we have to just put the things. Let my figure be here itself so that I can understand. So here the velocity is I cap 2 j cap. That means what is ux here? Ux is 1 meter per second and uy is 2 meter per second. Okay, 2 meter per second. Now then what is the theta? So how do you get theta? So tan theta, let us say tan theta. Tan theta means what? Let us say uy by ux. This will be giving you tan theta, because this is u sin theta by u cos theta. So that is what gives tan theta. So I'll be getting tan theta if I just say uy is 2 meter per second and this is 1 meter per second. So this is a dimensionless quantity 2. So tan theta is equal to 2 we have got. So y is equal to x tan theta into 2. So it will be 2x. So this part is gone. Now let me see what is g. G is given as 10 meter per second square. Meter per second square. And what is, let me keep this x as it is. What is u? U is actually, look here, u will be the modulus of the velocity. So this, if this is the velocity I cap plus 2 j cap, if this is the velocity, so modulus of this will be your u. Okay, that will be 1 square plus 2 square, that means 4 root over 5. So u is root over 5. So you just put here u square, that means 5 alone. Okay, and then cos square theta. So this is one thing we should just find out. So let me do it here. So we know that tan theta is how much? 2. We have already found out. So sin theta will be is equal to 2 cos theta, right? Now what is cos square theta? Cos square theta means 1 minus sin square theta. So which I can write as 1 minus 4 cos square theta. Okay, so this will be, again if you solve it, so this is 5 cos square theta is equal to 1. So cos square theta will be actually 1 by 5. Just solve and see. So this will get cancelled with this one, and this will give you 5 meter per second square into this. Okay, this is again, see, then it will be 2x minus 5x square. Okay, here also meter per second square will be there. Okay, so that's why it will get cancelled. Okay, so you get 2x minus 5x square. So this should be the answer. Let us see the options. I hope you agree with me. All the calculations are right. So the B will be the correct answer for this question. Okay, B will be the correct answer for this question. Okay, so the key point of this problem is that you should remember. I'll write here. Remember this. Okay, remember this, because not only this problem, you may get various kind of problems from this particular equation. Okay, this is the equation of trajectory at any point of time for a projectile. And see, this is the question from JEE paper 2013, JEE mains paper. Okay, we'll go to the okay, sorry, this is actually from 2014. This paper is 2014. I don't know why this blinking is coming up, and this is actually from 2018 JEE mains, and this is from 2019. Main. Okay, so such, so we have few problems like that. We'll just try to solve. Okay, so this is another problem. This is also related to kind of projectile only, but not exactly projectile. We can just in general treat a vertical motion, straight line, vertical straight line motion. I'm sorry, I don't know why it is giving a blinking. Okay, it's okay now. It is stable. So, oh, sorry, this is, there is a typo here. Okay, so this would be for. Okay, so for a tower of height h, capital H, let us say this is a tower. Okay, the base is the ground here. Okay, this is a tower. It has height something like h. Okay, a particle is thrown vertically upward with the velocity. So from here vertically upward, a particle is thrown. So from here it is thrown. Okay, with the velocity u. The time it takes, the time taken by the particle to hit the ground, that means it will actually come and hit the ground ultimately. Okay, it takes time that taken by it to reach the highest point of its path. Okay, then what is the relation between h, u and n? H means maximum, h means height of the tower, u means the initial velocity, n is the time, n is a factor of time taken by the particle to hit the ground. So what it is saying that, it is saying that, let me draw this tower somewhere in the middle or right hand side. I'll get some space to write also then. Suppose this is the tower. From here with u velocity, the particle has been thrown. So somewhere it has to come to a rest for a very short while, and then it will come down to hit the ground. Okay, to hit the ground. All right, so this is the scenario. Now what is the time it takes to reach the highest point? That, like, calculating that is anyway is going to be 0. So we can write final velocity is equal to initial velocity minus, it is actually motion under gravity, so minus gt. Okay, so since this g is 0, because the object has to come to a rest at the highest point. Okay, at the highest point ultimately it has to, I'm sorry, actually this will not be like this. Trajectory, I should not be drawing this trajectory like this. It will actually go like this, and come like this. Okay, like this. So this is the highest point. Say here the velocity will be 0. Velocity will be 0. So what is the time when the velocity is becoming 0? So we can find out 0 is equal to u minus gt. So t means u by g. Alright, so we'll write here this as t1. This is the time taken by the particle to reach to the highest point of its path. So this is t1. I have got this t1. Now the question is when this should come here. I'm just taking that it take time t2 to come and hit here, come and hit the ground. Then what we can write, actually we can write, see, we can write s is equal to ut plus half gt square. This we can write if we think from the highest point. But if we think, see, we have thrown it from some height over here. Okay, already this much height was there. So what we can do, we can write this formula. See, final height, like final s2 minus so1 is equal to ut2 minus half g t2 square. Okay, so this is what we can do. So if we see what is h, s2 is 0, that is the ground height is 0, and s1 is h already was there. What is u? You take that simple u, the initial velocity, and t2 is actually n into t1. T1 means what? T1 means u by g. The T1 I have already calculated. Now that is u by g. I'm just putting it here. T2 is equal to, say, T2 is equal to n into T1. That means n u by g. Okay, so that is what I'm just putting it here now. Half g n u by g whole square. So this is what we have. Now what we can do, we can just do a little bit of simplifications and see what we are getting. From here, look, I'll get n u square by g, and here I'll get 1g will get cancelled in anyway, so n square u square by 2g. Now if we take n u square common, excuse me, n u square as common, so we get 1 by g minus n by 2g. If we further simplify, then we get n u square. Sorry. Okay, I'll just remove this part now and write the final answer. Here itself. I'm sorry, there is. Okay, so we have this thing, we have to solve from here. So n u square take common, then you'll get 1 by g minus n by n u square we have taken, so n by 2g So we can just do LCM. So n u squared by 2z 2 minus n. Okay, and here in the left hand side you have minus 8. Okay, so upon further simplification we can see that h will be is equal to n u square. If I just multiply 2gh this side, so you'll get n minus 2 because there is a minus over here. So 2gh is equal to n u square whole into n minus 2. This is the formula we must be getting, or the relation between u and capital H will be this one. 2gh n u square n minus 2. So this D will be the correct answer for this question. Okay, I hope you are understanding. So what was the problem? I'll just repeat it. The problem was that from a tower of height h, a particle had been given an initial velocity u and thrown vertically upward direction. So if t2 is the time this ball takes to hit the ground, then this t2 is equal to n into t1. What is this t1? T1 is the time it takes to go up to the highest height. Okay, if this is the question, then what is the relation between h, u and n? And there are options given over here. So from there I could guess that this will be the probable answer, because see, s is equal to ut plus half gt square. So if we just use this formula and use the t2 value in place of t, we have to write t2. Okay, and t1 will be finding out v is equal to 0 is equal to u minus gt. So from here t is equal to u by z. So t1 is equal to u by z. So with that concept we have problem. So we'll move on to the next problem. So this is actually the option D. Now option so question third, this question is saying that all the graphs are intended to represent the same motion, same kind of motion. One of these, actually one of them does it incorrectly. So suppose we are trying to represent a motion graphically. So among except one, all of them actually representing the same motion. You have to find out what is that odd one. Pick it up. Okay, so you have to find out the odd one. I'll repeat the question. See, in these four, we are trying to represent, by these all these four graphs, we are trying to represent a particular motion, but one among these three will not be able to represent that particular motion correctly. So that you have to find out. Do you have any idea? Okay, let's see what is the nature of this curve over here. You can see that, see the number option A, the velocity at the beginning when the position was 0. Okay, velocity was maximum. Okay, and then velocity decreases and it comes to 0 again here. Okay, again from this side if you see, so the same thing will be seen. So just look this C1. If you see the C1, then you might be able to actually get some idea that what kind of motion is this. See, the position of the particle at t is equal to 0 is this one. Then it will just go this way. At certain point it will be at maximum point, and then it will be actually giving rise to this kind of curve. So this curve we have just seen, this is actually for a projectile motion, right? A projectile motion, that means for a vertical motion, for a vertical motion with constant acceleration, vertical motion with constant acceleration. With constant acceleration. Just a minute. Let me mute this. Anyway, so this is actually representing a vertical motion, okay, with constant acceleration. Look this D. Look this D. In this D also, the velocity was here a positive quantity. Then look, it is decreasing, and then it is going to the negative direction, right? That means the slope of the position, like this is representing the same thing here. Actually, this is the, okay, so I should not say G, this is a velocity, okay, this is velocity. So yeah, so this is also representing the same kind of thing with like a same vertical motion with constant acceleration. This also represents the same thing, only this one, you look the acceleration, since this is distance versus time curve, actually it has uniform velocity during this time, then another value of the velocity you will get at this, and then velocity is going to be getting actually saturated. That means it is velocity is going towards the zero, but not the other way. It is not going towards the negative direction at this given figure. So it is not actually showing indicating the vertical motion as like as such. So that's why this option will be actually the odd. Okay, all others actually representing the vertical motion, where you can see the sign changes happens. Okay, sign changes happens to the velocity. Velocity is actually this one now. Okay, in this case also velocity goes up and then come down. Here, as you see, velocity is actually negative. So the option B will be the correct answer. I hope I have given you enough logic why this is odd or wrong, because all others are actually representing the vertical motion. Okay, now we'll go to the fourth problem. In this problem, a particle is moving with velocity v is given as v is equal to b square root of x. Okay, this is what is given. Now, what is the question? What is the question? The question is calculate the speed. Calculate the speed of the particle at t is equal to tau. At t is equal to tau. T means time. So after tau time, what will be the speed of the particle? So we'll now try to solve this problem. So this is actually, see, if you want to find out the speed, how do you do that? See, one thing is that v is equal to sorry, s is equal to vt, right? This you know. So v is equal to ds dt, or in other words we can, okay, so this we can do it. Okay, v is equal to ds dt, but we don't know the ds. What is ds and what is the dt? We know it, in this way it is difficult to do. Now what is the good thing to do? V is equal to U plus A T. Since T is given after T time, so this will be your good thing to do. V is equal to U plus AT. Okay. So what is this A? A is the acceleration. Acceleration. A is the acceleration of the body of the particle. Now how to find out the acceleration? This is actually a question, because U is given, then time is given. Only thing is this acceleration. So I have got this as the formula. So dv dt is equal to, see, this b is a constant, okay, and at t is equal to 0, suppose the particle was at it at the origin, so this will give you 2 root x, okay, 1 by 2 root x, but we have done the derivative with respect to x, we have to do it with respect to t, so dx dt. So we have got b by 2 root x into v. So what is this v? V we can just replace from here. Look here. V you can replace from this particular given equation. So v by root 2x into v is again b root x. This is root x. Okay. So this root x gone. So ultimately what we get? B square by 2. Okay. So what is the acceleration we have got? We have got the acceleration from here is b square by 2. Now let us just solve this problem. We have got the acceleration. So what is this v? V is equal to u. U was b root x plus a. A means b square by 2 into t. T is actually tau. Okay. So let me. Okay, so actually there was a clue here. Take the particle at 0. Take the particle, or assume the particle is at the origin at t is equal to 0. So that is what has been told, and so the velocity also will be 0. So initial velocity would be 0. So b square tau by 2. This will be actually the answer. So the speed, so this b will be the correct answer for this question. Okay, so b square by 2. So this is how you have to move for solving problems like this. I'll just take up one more problem from this paper, JEE. So JEE mains. See, this question is saying that, this is a fifth question. Just a minute. So let us see the problem number 5. Okay. Sorry, it was problem number 5. The question is saying that a person standing on an open ground standing on an open ground hears the sound of a jet airplane coming from north coming from north at an angle 60 degree with the ground level. Okay, but it finds but he finds finds the airplane oh sorry, this should be together, airplane, but the airplane right vertically above his position. If v with the speed of the sound, v be the speed of sound, the speed of the plane, the speed of the plane the speed of the plane is option A root 3 v by 2, option B only v, option C 2 v by root 3, and option D is v by 2. Okay, v by 2. A person standing on an open ground hears a sound of a jet airplane. This is jet airplane. Okay, jet airplane coming from north. So the question is something like this. This is suppose north, this is south, this is east, and this is west. Okay, so the sound that guy is hearing, as if the sound is coming jet airplane coming from, so sound is coming from north at an angle theta. So this is the angle theta, 60 degree with the ground level. Okay, so if I just break this into component, okay, this also would give you This also would give you 60 degree. But the airplane is vertically at the above his head. So then what will be the speed of the plane? What will be the speed of the plane? So that is what has been asked you to calculate. Just give a thought. So you have to find out. Okay, let me go here. Sorry. Let me go here. The problem as I read out, we'll just do it like that. So actually we'll just see this thing in a little bit in different way. Let us say, I'm sorry, the jet plane. See, suppose there is a person sitting over here. Okay, sitting over here. Okay, he is hearing the sound of the jet plane. See, suppose, oh, I'm sorry. Oh, my straight line is going to be like this itself. Now, let me, great, yeah. So let this is the direction north to south. I'm just taking this as. So the jet plane, okay, the jet plane is moving in this way. Okay, in this way it is moving north to south, suppose. But the sound this guy is hearing actually like this suppose this is 60 degree. So the sound Vs and this is the Vp velocity of the plane is like that. Okay, the question was if the velocity of the sound is V. Vs, I'm just keeping this as V alone. This is V. Okay. Then what will be the velocity of the plane? See, it is actually the relative velocity you have to find out somehow. Or this is a simple vector problem we can think. This is a simple vector problem. It is nothing to do with relative velocity and all. This is actually a vector problem. Okay. This is 60 degrees. This is Vp. So what we can write is cos 60 degree is equal to what? This is the vertical. So cos 60 degree means base, and this is actually hypotenuse. So base by hypotenuse. So Vp by V. Vp by V. Okay. I'm sorry. It is actually, let us say sometime it was okay. So this is Vp into T. After time T, we are seeing at T. So this is the length actually you should be taking. Let me just give this a name. This I was just taking the vector itself as magnitude. So let me take this as A, this is B, this is C. So this will give you AB over AC. Okay, AB over AC. What is AC and what is AB? AB is actually Vp into time t after starting the motion or after observing starting of observation t times elapsed we say, and AC is actually V into t. So as we are doing Vp by V is this. What is this cos 60 degree? Cos 60 degree is equal to half. So what do we get? Vp is equal to 2 into V. So 2 into V. Oh no, 2 Vp is equal to V. So Vp is equal to V by 2. So V is the velocity of the sound. So Vp, the velocity. So what this replies that the speed of the plane airplane Vp is equal to is half of the speed of sound okay. So V by 2. So this we can see the options over here. So V by 2, this one will be the correct answer for this question. Okay, V by 2. This is actually a simple, very simple, uh, very simple problem of vector. You have to just do it with attention, then you will get the answer. Okay, so with this we'll stop it here for today. Next day we'll take up few more problems. Just take some problems. Obviously this is a very big topic like kinematics. There will be at least a problem from this uh, topic kinematics in either, both in NEET and JEE. So we'll actually try to uh, solve as many as problems, like as many problems we can do in our classes, okay, from each chapters. So thank you for your patience. Bye for today.